All right, guys, we are ready to do 6-2. So the plan is that we will do this in class. If you are in class this week, if you are absent or if you didn't get a chance to hear the whole thing, you want to rewatch it, then you would want to do this at home. So chapter 6, section 2 says a parallelogram is a quadrilateral. Quad we recognize means 4. If both pairs of sides, opposite sides, are parallel. So it has 4 sides, opposite sides are parallel. Did you see this? Okay. All right, let's do a couple things that we need to know. It says if a quadrilateral is a parallelogram, then, so there's all kinds of quadrilaterals, but not all of them are parallelograms. This is the things you would look for. First of all, opposite sides. We already said opposite sides are parallel. That was in the definition. They're also congruent. So opposite sides are equal. Those sides are the same length, and these sides would be the same length. Okay. Opposite angles are congruent. Let's draw another one here. Opposite. So this angle would be congruent to this angle. They're opposite each other. And this angle would be congruent to this angle. Opposite angles are congruent. Okay. This picture in the middle shows the parallel. These ones with 1 arrow, those sides are parallel. And the ones with 2 arrows, those sides are parallel. Okay. This one says consecutive angles are supplementary. So do you remember supplementary? Their sum is 180. So let's draw a parallelogram. And consecutive means they're right next to each other. So if I've got an A and a B, those 2 angles are right next to each other, then the measure of angle A plus the measure of angle B is 180 degrees. Now, it doesn't have to be only those 2. You can pick any 2 consecutive. So these 2 angles are right next to each other. Their sum should be 180. These 2 are right next to each other. Their sum should be 180. And also these 2. So any of the 2 complement or supplementary are the ones that are consecutive. I should have said that the other way. Any 2 consecutive are supplementary. Okay. If it has 1 right angle, it has 4 right angles. So parallelogram, if 1 angle is 90 degrees, remember then the opposite one has to be 90 degrees because this says opposite angles are congruent, and consecutive or supplementary, they add up to be 180. So the ones right next to each other, if this is 90, this one has to be 90 so that their sum is 180. So if 1 angle is the right angle, then all those rules kick in and automatically all 4 of them have to be right angles. So you only have to know 1 is a right angle to know for sure that all 4 are. All right, let's try to use some of this on parallelograms. It says if ABCD is a parallelogram, find the value of each variable. So we have, looks like there's some A and some B's we need to solve for. And I'm noticing A's are on opposite sides. Remember, parallelograms, opposite sides are congruent. So they are equal to each other. And since they both have A's, that works out perfectly. We'll set them equal to each other. 2A equals 3A minus 5. Okay, that's just those 2 sides that are congruent. And then we do a little bit of algebra. I'm going to subtract 2A from both sides. So I have 0 equals A minus 5. And then add 5 to both sides. So 5 equals A. Okay, we did that one. Solve for A. Now to solve for B, well, they're on opposite sides. That works out great because opposite sides are congruent. which means they're equal to each other, so we can set them up equal to each other. 2b minus 1 is equal to b plus 3. And then we'll solve for b. I'm going to subtract 1b from each side. And then add 1 to both sides. So b equals 4. Okay. All right, that's when, and it says up here, that's how it works with sides. We also have a parallelogram with angles. So let's remember what we know about angles. Let's look up here. Opposite angles are congruent. Okay, let's see what they gave us. Oh, we have another one, don't we? Consecutive angles are supplementary. So there's two things that we know that would be helpful when we're working on angles. Okay, parallelogram. Opposite angles are congruent. I'm noticing though one says y and one says x. So it wouldn't really help us to set up an equation that has two variables in it. Let's not do that one. Let's see consecutive. Yeah, I think we need to use that consecutive one. So consecutive angles right next to each other, they're supplementary. So if I add those together, it should equal 180. Let's do that. 6x plus 12x equals 180. And that works out great because now we just have one variable and we can solve for it. These are like terms. 6x plus 12x is 18x. And we'll divide. X equals, and then we put that in our calculator if we needed to, and get 10. Okay. All right, so the supplementary one helped us. Now we can take, there are two different things we could do. We could go ahead and put these two together. They're consecutive, so we could say 3y plus 6x equals 180. The other thing we could do is put these two together because they're opposite, and opposite angles are congruent. So we could say 3y equals 12x. So whichever one you think sounds easier, I actually think 3y equals 12x sounds easier to me. I know x is 10, so I'll plug that in, 12 times 10. And that means 3y equals 120. But I just want one y, so we'll divide. Y equals 40. Okay. All right. Now, one nice thing about having this on a video is if you need to rewind and watch it again, if I'm going too fast, go back, watch it again. See that one more time. Okay, I've got two here for you to try. One is focused on the sides and one is focused on the angles. So pause your video and try both of those, solve those for the variables, and then come back and we'll check them. Okay, I'm noticing that opposite sides, which should be congruent, that's the thing about parallelograms, have a. They both have a in them. So let's set that up. 3a minus 4 equals a plus 2. Move the a to the other side. Move the 4. So we're getting the a on one side isolated and all the numbers on the other side. 2a equals 6. A little bit of dividing. And a equals 3. Okay, is that what you got? Yay. All right, then let's work on the other sides that have b's. So b plus 1 equals 2b. I will subtract and get my b's on one side of the equation. Oh, well, that ended pretty quickly, didn't it? B equals 1. Okay, awesome. Now, if I wanted to check that, I would plug that in. So where there's a b, I should put a 1. 1 plus 1 is 2. And if I put it over here, 2 times 1 is also 2. So that works. Those are equal to each other. And I can do the same thing with the a to check it. Angles. So I know that opposite angles are congruent. Oh, and look, that's just a 44. So there's not two Different than last one that we did, we don't have two variables when we take the opposites. So y equals 44 degrees, or we could just say 44 for this one. Then we have to say, okay, but to solve that x, I need to find a different method because his opposite isn't there. So we'll have to break out that supplementary consecutive one. X plus 44, they're consecutive, they're right next to each other. X plus 44 should equal 180. Okay, which means we just need to subtract the 44 that's on that side, and 180 minus 44 is 136. And I'm going to put degrees on that one too, but you don't have to do that. Okay, so we solved that. Both of those, not too bad. All right, let's turn the page over. On the back side. Okay, still parallelograms. We want to look at the diagonals. And we talked a little bit about diagonals in our last video when we were drawing diagonals across the polygons to see how many triangles we could make. For a parallelogram, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Do you remember what bisect means? Cuts them exactly in half. So the diagonal this way, they cut each other exactly in half. So this half is equal to this half. And on this other diagonal, this half is equal to this half. They're not necessarily all equal to each other, but they're equal to the other half of their same diagonal line. So the diagonal gets cut exactly in half. Okay, the other one says, each diagonal separates the parallelogram into congruent triangles. That could be useful. If I have a parallelogram and I'll put a diagonal this way, then I've just created two congruent triangles. So we know, for instance, that these sides are the same. They're congruent. These sides would be congruent. Opposite angles would be congruent. This angle would be congruent to this angle. So we've set up two congruent triangles. And we know a lot about triangles, right? We did a whole chapter on those. Okay, let's see what happens then. Example 2, find the value of x and y in parallelogram ABCD. X and y. So here's an x, here's a y, and then we've got a 24 and an 18. This, I'm going to look at this diagonal first. We know, since it's a parallelogram, that this diagonal is cut exactly in half where it is intersects the other diagonal, which means this piece and this piece are exactly equal to each other. 6x and 24 are equal. So let's solve that for x then. If we set that up, 6x equals 24, we have an equation with just x in it, so we can solve this. Divide by 6, divide by 6, and x equals 4. We got 1. Let's see about the other diagonal. Has the y. Okay, so this diagonal is also cut exactly in half. This piece is congruent to this piece. So 4y is congruent to 18. 4y is equal to 18. We'll do some dividing. Y equals, oh, we get a decimal on this one. 2.5, 2.5. Oh, 4.5. Phew. Okay, 4.5. All right, we did it. We solved for x and we solved for y. So I've got one here for you to try. Pause your video and work on that for a second and then come back. All right, let's see. So we split this diagonal exactly in half. 3x is equal to 12. And then to solve that for x, divide both sides by 3. X is 4. Is that what you got? Yay. Then the other way, so this one is split exactly in half also. 8 is equal to 4y. Divide by 4, divide by 4. Y equals 2. All right. Okay, last piece. This says ABCD is a parallelogram with side lengths as indicated. Ooh, the perimeter is 22. So all around the outside, if we add that all together, it's 22. And then it says find AC, just this one piece. Okay, well, what do we know? We know this side is congruent to this side, but they didn't give us a measurement. So we know those are both 2x. We know these sides are congruent, but they didn't give us a measurement over here either. So on every side, we have a representation, but not an actual number. We do know the perimeter is 22, so if we add all the sides together, it equals 22. That's actually enough then. We can solve for x using that equation and then go back and plug it in to find AC. So let's set up. The perimeter is 22, and that's when we take all 4 sides and add them together. So 2x plus x minus 1 plus 2x plus x minus 1. So that's all 4 sides. But there's only one variable, so we can do this. If there were x's and y's, we wouldn't be able to. But we have just x. So let's get all our like terms together. 2, 3, 4, 5, 6 x's all together. And then we have a minus 1 and a minus 1. So minus 2 together. So we combined our like terms. And now actually this looks more like one that we do all the time, right? We're solving for x, so we need to move our 2 to the other side, 24. And 6x is multiplied by 6, so we'll divide by 6. X equals 4. Okay. That's good, except that this is what we needed to find. Find that length from A to C. So now we can go and say, since we know this, x is 4, and AC is equal to x minus 1. Let's put in 4 minus 1. AC is equal to 4 minus 1. So AC is equal to 3. Awesome. Okay. All right, you guys have an assignment, 6-2, that will be due next time we come to class. And you also need to work on 6-3 this week. So we had 2 pieces, 6-2 and 6-3. All right, let me know if you have any questions. I'll see ya.